Hello, welcome to a new series of Geometry Nodes tutorials. These short tutorials are going to be aimed at developing architectural objects, and the goal is that at the end of this series, you're left with a collection of tools that can help you sketch parametric objects as part of the design process to help you iterate, to help you prototype ideas. And just for example, just as an example, I'm going to show you this project right now, which we're going to be developing today. We start with a very simple parametric cube, but the interesting thing is that I wanted to make a perforated panel uh, um, sketch, snippet, geometry node tree, however you want to call it, noodle soup. So the idea with these parametric perforated panels is that you can control, for example, the size of the panels, then you can move an object around to change how much you perforated them. But then this kind of evolved a little bit into something else where, well, you can change the size of these. You can change the minimum size, so all of them have a little bit of a gap, a little bit of a perforation. But then as this started evolving even more, then I started adding extrusions, so it became something completely different, adding a little bit of a thickness into it. And then by changing the size, this kind of became not a perforated panel anymore, but more like a architectural thing itself. And I think this is kind of the power of this parametric generative workflow, that sometimes you start with something in mind and you end up with something more cool that allows you to sketch, prototype. And the thing here is that Blender and geometry nodes are kind of overpowering. So taking advantage of these tools for developing architectural projects, I think can be very, very useful. So I hope you guys find it useful too, and let's get started. Alright, so hopefully this is not the first time you open Blender. If it is, I'm gonna put a couple tutorials for you. The first thing I'm gonna do is I'm gonna go to the geometry nodes workspace. I'm gonna resize this a little bit, and I'm gonna add a geometry node modifier to the cube. So all I'm gonna do is click here in new. Now to make it easier to follow up, let me activate the screencast keys. It's activated, but I think it got bugged. And now you should be able when I'm pressing here. So geometry nodes, as you can see here, it's a modifier. So it's taking some geometry, doing something to the geometry, in this case nothing, and outputting that. So if we disconnect this, now we're not outputting anything. We still have the cube in there. If we click tab here in edit mode, you can see that the cube information is still there, but we're not doing anything with that information. So what we're gonna do is Shift A to create, to add a new node, then search for cube, and then connect this cube to our group output. And now we have the same cube, a little bit smaller, but parametric, so way cooler. We have control of how many divisions we want on each side and what is the size of this cube. I'm gonna go back and reset this. So the first thing I'm gonna do is I want to drive those subdivisions based on a panel size. So as this is gonna be becoming more complex, what I'm gonna take advantage is that I can connect my inputs here to my group input, and what that's gonna do is gonna generate a UI accessible modifier here that allows us to change those values without having to go and find those parameters in our nodes. So we have the size here, the size input going to the size of a cube. So now we're gonna need to drive the sides, the divisions on the cube based by a panel size. So let's do that first. I'm gonna take this out, go through math, divide, math, divide. There you go. So also you can find them. You go to Shift A, Utilities, Math, and then Math, Utilities, Math, and then Math. You can find that this node here. So the first value is gonna come from the size. So Shift A, or even better, I'm gonna drag this out, separate XYZ, XYZ, and I'm gonna plug in each of my directions to the first one of my divide inputs. And then we need the value, so I'm gonna connect my value to the node underneath the size, and I'm gonna repeat the same with this. Oh, I made a mistake. I don't want to do that, so I'm gonna disconnect that. And a cool thing is that when you make mistakes like this, I'm gonna press the end panel here because I don't want these values anymore, and then I'm gonna scroll down a little bit and delete these two that I'm not gonna be needing. So what I'm gonna do is connect all these values to that value in there, and I'm gonna rename this as panel size. There we go. So right now, if I connect those divisions to each one of my vertices that I want on each side, you can see that depending on the value that I give it, is gonna add more divisions. So if I make the panel size smaller, I get more divisions. Now, there's a small problem that maybe you already caught. If I put 1.5, to make it easier, I'm gonna put 1, 1, 1, 1, and I'm gonna use 0.25. So currently I should be getting 0.25 size panels, but I'm getting 3 panels, so it's not correct, and that's because these are the vertices. So if I divide by this, what I'm getting is 3 vertices. So in order to correct that, what I'm gonna do is we need to add 1 to this. So I'm gonna Shift D, click here, add value 1. Then I'm gonna connect that on each one of my divides, and now it should be correct. So if I have 25.25, we get 1, 2, 3, 4, and if I have dot 33, I have 1, 2, 3. You can also add a seal or a floor in order to cap it, but I like to keep it like that. And then, as you can see, as soon as it changes size and it reaches a new integer, then it jumps to the next amount. So really handy. All right, now the next step after we got our panel size is gonna be we're gonna grab each one of these faces and we're gonna insert it and delete that inserted, the middle part of the insert face, so we can have our perforated panel. And for this, we're gonna do a quick of a trick. We're gonna actually extrude, so Shift A, extrude mesh. And then what we're gonna do is Shift A, search, we're gonna scale element. In this case, we wanna scale the face, and our selection is gonna be our top face. Now what this is gonna do, I'm gonna bring my extrusion to 0, is that now when I change the scale, you can see I'm doing that offset that we were talking about before. Now if I go to solid mode, nothing is happening because I need to delete that middle. So geometry, delete geometry, face, not everything. I just want to delete the top side. Okay, so we have a perforated cube, but currently it's not being driven by anything. So the next step is gonna be to add either a texture or an object that allows us to control that. And in order to do that, the first thing is let's create an object here. So Shift A, in the 3D view, Shift A. I like to use icospheres for that. I'm going to scale it down. This case is going to be a very basic driver, and then you can look into how to use textures or how to use faces or other things to drive your sizes. But I'm just going to go into the basic of using the origin of this cube to drive the size of the perforation. So let's bring this icosphere information into geometry nodes. So Shift A in the node editor, input, no, object info, I think it is, object info, here it is. I'm gonna grab the eyedropper, select my icosphere, and then what I'm gonna do is I'm gonna use the distance that there is from here to each one of the faces to drive the scale of that hole. So for that, what I'm gonna do is, here's my scale. This scale here is what we wanna drive from it. So for that, we're gonna need a distance. So I'm gonna go to math, vector math, not the normal math. You can see they're different because the color changes and because it's gonna perform a math operation on a vector, not on a number. So we wanna use distance, and all this is subtracting, so it just concentrates a bunch of math that we need in one node, which is very handy. And what we're gonna need is not the distance from 0 to 0, but what we need is gonna be the distance of the face to the icosphere. So Shift A, position, and this is probably one of the difficult concepts to grasp, but right now what we're doing is, this is kind of a self position of what, and then you can know of what by going down into the nodes, and it's of the face, right? So the position of each face. So this is really cool because what it's gonna do, not center, scale, is gonna drive that scale by the position distance to the location of my icosphere. And we're almost there. Now what we need to do is fine-tune this so we don't get these weird values. So we need to clamp it and probably map it. So map it and clamp it so we don't get that weird error. Okay, so the next step now is going to be to get some control over these perforations. The first one that I'm going to use is going to be a map range. Map range. Oh, sorry, not the map range first. I'm going to use a color ramp. And the reason for that is that the first thing I want to do is to invert this. This is going to help us invert everything really quick. So if you want to invert the direction of which ones are big and which ones are small, this one is going to help us change that. So also, as you can see, this is helping us clamp it, so we're not getting that offshoot anymore that we had before. So let me invert this, and now wherever the ball is closer, the perforations are larger, which is what we want. So we have it clamped now, and now what we want to have is to guarantee, for example, that we get a small perforation on every face. If that's what we want, we can add a little bit more control. So we can do a map range, put it here, and then vector, color to vector, from 0 to 1, that looks good, to min to max. So here what I'm gonna do is I'm gonna create on my group input 2 new values. I'm gonna call them min and max. And what this is gonna help me is gonna help me dynamically change what's gonna be the maximum size for these perforations and the minimum size that I will get on every perforation. So I'm gonna connect to min, to my min, and to max, to my max. And now if I select the object here, right now the minimum is 0, but now I can guarantee that I can guarantee that there's a minimum size in there. And now it should also be capped by my max. So if I go here to 1, for example, it will be as before, where the maximum size is the size of the panel, but then we can go a little bit smaller like this. So now they're a little bit smaller. So this gives us a little bit of control over the sizes that we're gonna be getting. All right, now, if you remember correctly, something that we had before that I think we should keep is that we can extrude this and then have these really cool looking blocks or like truncated pyramids as panels. So the first thing that you can see is, well, first let's have this driven from the outside. We'll call this parameter driven from here. So what I'm gonna call this is gonna be panel extrusion. And the first issue that you see is that it is infinitely thin. There's no thickness to it, and it's easy to see that that's an issue. So what I'm gonna do is I'm gonna kind of give it some thickness. So I'm gonna extrude, mesh again. Whoa, not individual. That look cool, but not what we're looking for. And then a lot less than that, so 0.1 maybe. And as you can see, we have this kind of feeling of thickness, but the issue is that that's only true from the outside, not from the inside. So what I'm gonna do is, I think if we go back to these scale elements, we have that geometry before we extrude it and scale it. So what I'm gonna do is I'm gonna take this one here, use the joint geometry node here. We'll first separate geometry, and what I'm gonna do is I'm gonna separate that initial part, the opposite of what we had before. So I'm gonna go to the, not this, I want the inverted, and then I wanna join this to here, and that's my output. So if I did this correctly, right now, I think it is there. Nope. So let me think what's happening here. We have the scale element, then we separate the geometry, and then what we're gonna do is we're gonna add the inverted thing. Oh, I never gave it a selection here in the separate raw material. So we want this top geometry, the same one that we have in the scale element. And now, if everything's correct, it should be there. It looks weird. Not sure what's happening. Oh, not point face. Sorry, but okay, that's what we want. Good. Looks good from the inside, looks good from the outside. We can drive this from our attractor. I don't know how to call it. We can change our panel size to make a lot small ones. We can change that thickness, that panel extrusion. We can change the thickness here. Let me add this already. Call it thickness. So we can make thinner concrete. We can move this around. Yeah, pretty cool. And then the last thing I'm gonna do is I'm gonna add a subdivision surface. Subdivision surface. That is the trick that I use to make it look like that. And all you do is you grab the level here, connect it to an output, and you can call this subsurface. And that's it. This is really everything I did, and you can play with it. I suggest you test how else can you drive these perforations. You can add some materials, some lining. I can make a quick video about how I did that procedural concrete. It's really easy. But yeah, that's it. Hope you enjoy it. This is the first snippet, and the goal is to make one every week. So hopefully see you next week or maybe a little more. Bye.